Magnetism. We're going to start with a quick punctuated history showcasing a few of the important scientists for magnetism. So here are your priming questions. We're going to go ahead and move on. So, magnetism. The term magnetism itself stems from lodestones that were found in Magnesia, Greece, about 6th century BC. So this trek started a long time ago. Now, lodestones in particular are a special type of magnetite. Now, you want to be careful. Not all magnetite ores are lodestones, but all lodestones are magnetite. We'll talk about why these lodestones are special later on in the presentation. So again, this comes from Magnesia, Greece, where they were originally discovered. Now, around the same time that lodestones were being discovered, there were also separate accounts of electricity, specifically relating to biological organisms, such as fish and some other marine animals. And so some people were experimenting and discovering things about electricity at the same time that they were figuring things out about magnetism. Now, at this time, they were still very separate to the scientists, and in fact, one didn't really know about the other. Okay. Now, as far as magnetism goes, the early Chinese were able to make spoons out of some of these lodestones, and they were able to form these spoons into early compasses. And so these were lodestones that were magnetized, and they became the compasses. And later on, they were able to use the lodestones to magnetize iron, float it on water with cork. And what they noticed was that the needle, the iron needle, would align itself regardless of where the water bowl was located. And this is aligning to the Earth's magnetic field. Now, in the 1300s, the dry compass was invented. This is what eventually became very common and the type of compass that you are familiar with. And so you want to think about how compasses work. They align themselves to the Earth's magnetic field, which is also interesting in that the Earth's magnetic field switches roughly on average every 200,000 years, but there's a big range for that. So, in the 18th century, many experiments and inventions during this time regarded electricity, still separate from magnetism. So this is important. Right now, during the 18th century, everything was separate to the scientists. They didn't realize that electricity and magnetism were the same. And in fact, as we've talked about in class before, Ben Franklin's experiment, a very dangerous experiment, unified electricity and lightning. Before Ben Franklin did this, they had no idea what lightning was, and they thought it was something different. Ben Franklin was the first one to use the Leyden jar, which is what I showed you with the Wimshurst generator, the Leyden jar, and was able to store charge from the lightning strike into the Leyden jar, unifying electricity and lightning. And this is also the time that batteries were being discovered or invented. This is when we talked about Coulomb's law. This is when they were able to do the experiments for that, and when they also started to understand things about voltage. So the 18th century was a really busy time for scientists in terms of electricity. Now come to the 19th century, a lot more work was done on the battery and different battery chemistries and what we call electrochemistry. Different reactions have different potentials. And this is when we really first start to understand the idea of current, which we talked about just a little while ago. And what they realized, at least Hans Christian Ørsted, was that when there is a current going through a wire, it causes a compass to deflect. And so there were ruminations before this of some interactions between electricity and magnetism, but Ørsted was the first one to really solidify the link between electricity and magnetism. So he was the one that unified the two ideas, saying electricity and magnetism are the same force. And then from here, Ampere built on his ideas, and that's also where we get the unit for amp from this scientist. Now, hopefully you've been following along with the order of history, and does it remind you of the order of this term? So think about that. From here, Michael Faraday and Joseph Henry, they make great strides in what we call electromagnetic induction, which is when you have a wire that's moving through a magnetic field, it causes an electric current. So an electric current is produced as a conductor moves through a magnetic field. Or if you have wires and you can move a magnet inside of it, that will cause a current to go through those wires. And this was a big deal because of its implications and what we use it for. So if you think of this, we have wire that's moving inside a magnetic field. Does this remind you of anything? Think back to what we did before Christmas break, the day before, and the application of that. So we use these concepts to build our generators. We built motors, which are sort of the opposite of generators, before Christmas, but these generators are what produce the electricity for all of us, for our school, for our houses, and this is what we also have in our homes for some people with backup generators. But these generators are what produce and allow us to have electricity and run things off that electricity. So this is a big application for electromagnetism. And from then through now, there have been many scientists, and I've skipped over a lot, who contributed to our understanding of electricity and magnetism. But this is, again, a punctuated version of the history.